Okay, let's look at what I would call a classic inclined plane problem. So this is the bare bones common problem that everyone should know how to do. Okay, so this problem is about a skier who's at the top of the hill, but we're going to draw our skier like a box, and we're going to put the skier in the middle of the hill, and we're going to turn them into a dot. All right, so my skier has a mass of 65 kilograms. So my skier has an FW equal to mg, and that is 65 times 9.8. And so my skier has an FW of 637 newtons. All right, so there's also a normal force. The skier pushes into the hill pushes back onto the skier, and we're going to dot the extension of that. There also is a tendency of the skier to want to go down the hill, and so that is the parallel force, and I can write that back up here. And this is the normal force, and if I want to close up my parallelogram, I could do that, and we know that friction is going to act opposite. All right, so we have to be able to calculate all of these values. Quite simply, the parallel force is always FW times sine of theta. And let's pause for a second with theta. This is theta here, the height of the angle of the hill, and this is the identical theta, and you can see how FP is opposite theta. That's how I know this is always going to be sine. Fn, the normal force, is adjacent to the theta. That's how I know that this is always going to be Fw times cosine of theta. And friction, I'll write that up here, friction is always going to be mu times Fn. So if you can remember these four things, then you should be able to solve any inclined plane problem fairly quickly. All right, so let's just do some quick number crunching. So here we would have 637 times sine of 20, and the parallel force turns out to be 217.9 newtons. The normal force is 637 times cosine of 20, and that turns out to be 598.6 newtons. And then the friction is equal to the coefficient of friction, which in this problem is 0.24 times 598.6, and friction turns out to be 143.7. All right, the next thing that I like to do is I like to write the key values then on my picture. So the FP, the downward force, is 217.9, and the upward force, not upward force, but the resistance force is 143.7. So you can see that the skier wants to go down, but there's some resistance acting on him. So we'll write down F net equals MA. And it's going to be the downward force, we'll call it the big arrow minus the little arrow, equals MA, and we are trying to calculate the acceleration acting on the skier. So that's going to be 217.9 minus 143.7. The skier has a mass of 65, and we find out his acceleration is 1.141 meters per second squared down the hill.